Mayank Shrivastava is one of the original creators of Apache Pinot. He's a member of the Pinot PMC. He's an engineering leader at StarTree, whose team works on, you guessed it, a lot of Pinot. And today we talk about some of the historical developments of Pinot as it moved along. As LinkedIn was adding new use cases, it kind of imposed challenges on Pinot in each stage of its development. And we dive in, talk about lots of internals, a very technical episode, in the inside of Pinot and how those things came about. So listen in with us. I learned a lot. I hope you do too on today's episode of the Real-Time Analytics Podcast. Hello and welcome to another edition of the Real-Time Analytics Podcast. I am your host, Tim Berglund, and I am joined today by my colleague, Mayank Shrivastava. Mayank, welcome to the podcast.
Thank you so much, Tim. I really appreciate you having me here.
Oh, of course. My pleasure. So you are an engineering leader at StarTree. And today I want to talk to you about kind of how Pinot has gotten to where it is. Recently, Kishore Gopalakrishna was a guest on the show, and he talked about really the birth, the genesis of Pinot. But going from there, it's a fun story. I want to talk about it.
Yeah, absolutely.
Tell us a little bit about yourself, what you do, and how you got to where you are.
Absolutely, yeah. So first of all, big fan, Tim. I think I mentioned this to you a while back, where I think it was the first time we met in person, where I was in a different domain before joining LinkedIn and getting into this distributed systems. Watched a lot of videos and about distributed systems from you, and so thank you so much for that. Something about me. My name is Mayank. I am one of the original team members who helped build Apache Pinot at LinkedIn, along with Kishore, Shong, and a few others of the team members. And then I was responsible for scaling there for different use cases at LinkedIn. Here at StarTree, I had the core data infra, which is Pinot, and the broader data platform.
All right, there you go. So your team actually works on Pinot. There are Pinot committers on your team.
Yes, nice. There's Pinot committers, and then there's people also working on the what we call the data platform on top of Pinot. Yes.
Sure. So there's, I guess, important. I mean, this is about the history of Pinot, but as that history unfolds, there's Apache Pinot, and there's that community. There's the PMC. There's the committers, and that open process. Yeah. And then there's StarTree Cloud, which has Pinot in it and other things.
Yeah.
And
we'll be glad to share about that as we
will
forward.
Always be careful to differentiate between the two because it matters. But
yes, absolutely.
Anyway, take us from after there's this first version of Pinot. Folks, if you didn't hear that episode, I'll make sure it's linked in the show notes. It should be just a few episodes ago with me and Kishore. But where did things go from there?
Yeah, absolutely. I think, as Kishore may have said already on this, it was a huge success, and not in terms of the scale and the cost, but it unleashed a lot of end user or LinkedIn member-facing analytics at LinkedIn. And some examples of those are, things like all the analytics that you see on your articles, videos, shares, likes, and so on. Every number out there is actually a query to Pinot.
Okay.
But that's the easy
look at those numbers a lot.
Yeah, definitely. But what when I look back and see, I think there's two things that happen. One is, we all know that necessity is the mother of invention. But in our case, it was that, along with the ambition of the team to always keep venturing into areas where one would think they don't belong, right? And that kind of took a turn for the good, for the better. And I can start with a story here where the LinkedIn feed team actually was running into issue. Well, okay, over that. So in LinkedIn, when you log in, there's a feed which is personalized for yourself, right? So there's some algorithm crunching some numbers in the background to find the right relevant feed for you. And one part of that is like, let's say you looked at the feed and then you hit refresh in a couple seconds. The feed has to change. If the algorithm ends up reporting the same, giving the same items, it's bad user experience, right? So there's a step
Right.
called impression discounting, which kind of takes into the fact, oh, I've already shown these items to this person or this member at so and so time, and this was the position and what where it was showed in the feed, right? So, and that just becomes a input to the algorithm to kind of re-rank the feed items. That was being powered by a key value store, primarily because high throughput and low latency, right?
Yeah, it has to be
Uh,
fast, and you can make key value stores fast, and so that
yeah, yeah,
seems obvious enough.
yeah, yeah. So this is where I think our ambition kicked in, right?
Okay.
Because we were doing really well in the OLAP space, but it was like, hey, what can we do next? And for this particular problem, it was running into issues where you have to, for a key value store, you kind of have to pre-cube everything up front, which leads to write amplification, storage, explosion, and so on and so forth, right?
Mm-hmm.
And more importantly, these are fixed cubes. So if an ML engineer wanted to play with the model, or rather the parameters, and say, hey, I want to discount not just for the last 1 day, but last 3 days or 5 days, all of a sudden you're talking about regenerating the entire set of queues for the whole historical data and then pushing back. So bootstrap is an issue, right?
Let's call that a significant batch job.
Yes, absolutely.
Yeah.
And so these things, while they were working well, were putting a upper ceiling on what a system that was a lot more flexible could unleash, right? And that's where Pinot came in, and we said like, hey, well, let's see if we can solve this problem with Pinot. And sure enough, when we first started, it was not ready, to be really honest, right? We had solved the who viewed my profile use case, but it was a different kind of challenge in terms of we knew the query up front, the data size was different, and so on and so forth. And here we're talking about a lot more read QPS, because think about people check how often somebody checks who viewed their profile versus how often somebody logs something like that.
Big
Right?
difference, hopefully, right? I mean,
order of magnitude at least, right?
Yeah.
And that is when kind of Pinot, we felt like, okay, this is a good place to, or a problem to push Pinot into the next level.
Mm-hmm.
And what we ended up doing is thorough analysis. I was kind of like the lead of the project at the time. And we kind of, a lot of good features today in Pinot came from that project. So we ended up figuring out things like, partitioning, for example, or the impact of pruning data upfront as much as possible, so that you don't need to look at a single byte that the query doesn't need. Right? That was kind of like the ideology.
Pruning in terms of the read path or ingest?
Read path, yes, read path.
Okay, so in other words, I forget who it was, but somebody on the Pinot team said, you can either scan less or scan faster, and that's in the scan less bucket.
Absolutely. Yeah, that is our philosophy. We try to scan as little as possible, or the most relevant for Pinot, right? So partitioning, all the partitioning support that Pinot has today came out of that project, or because of that project. Things like, we also found while encoding using dictionaries is a good compression technique, for high cardinality items, what ends up happening is each dictionary lookup is a dereference, and therefore you're jumping back and forth or at random seeks to disks, right?
Right.
And but in this particular case, we knew that the data is sorted by a primary key, so every other column should have locality of reference if you did not use dictionaries, for example, right? So that was another big one. To kind of have an indexing or storage mechanism which can give you locality without having to have dictionaries as another point in lookup, right?
I don't know if we can do this without a whiteboard, but I have a question about that.
Yeah.
Locality, if you want, so you said you're not using dictionaries, or in this case, you are using dictionaries.
Yeah, I can walk you through that, right? So think
Walk me through it,
of,
because the locality sounds like
yeah,
I want to know locality in what sense. So walk me through it, and I'll see if I still have the question.
Yeah, sorry if I'm jumping fast. I
Well, I
definitely.
mean, you're, to be fair, a lot better at Pinot internals than me and pretty much anyone listening, so it's okay. So let me just take us through that again.
Yeah. So let's say you are logging on to LinkedIn, right? So you have a member ID in there, and the feed service or the feed ranker service gets a request for you, and then in the end, it has to generate a feed, and it's essentially the read that's happening to Pinot is, tell me all the items that were shown to Tim in the last 7 days or 15 days. And,
Gotcha.
order them by time and, some other dimensions, something like that, right?
And to be clear, those shown to things are ingested from Kafka. Those are events.
Yes. So great question. So it's not just reads that's happening when you log on. It's actually writes to Pinot as well.
Right.
Because whatever is shown to you now becomes writes to Pinot for the next time.
Yeah.
Right. So now this data is several, maybe tens of terabytes in compressed form in Pinot. Now, if we knew exactly which partition and which segment Tim's data is in, right, we can just go in there and just fetch that part of the data. Now, that's just the partitioning part. But let's say your data is in, one segment per day. So there are like 14 segments for you. Segment is a Pinot horizontal
chunk
chart.
Of the table.
Chunk of the table, right? Now, what ends up happening is within that chunk, every column, it's a columnar storage.
Right. So the columns are not necessarily, you don't have locality in that sense. You've got separate columns because that's what you want. Yeah.
Right. So now if we can improve the locality of the columns or values by sorting on member ID, so all of Tim's data in one segment will be local to some part of the segment.
Yeah.
Right. So that's so far so good. So now we got to your set of rows, but now let's say we have to fetch values for other columns, and those columns are dictionary encoded. So what ends up happening is the forward index of those will have dictionary IDs in them. So you will probably make one disk fetch or disk seek to get all the dictionary IDs for that particular column. And these IDs may now be, the actual value may be sitting at different sectors of parts of the disk. And that will cause that fan out, right? Because of that use of dictionary.
Okay.
Does that make sense?
Yeah, that does. And so what did you do? You didn't want that. So now how did you fix that?
Yeah, exactly. So we came up with, a technique where we say that, okay, dictionary is good for compression, but it has this, one level of dereferencing. So how about we just, for certain columns where we know that this thing actually can be useful, let's see if we can use the raw data in a compressed form so that, we know that this is a high cardinality item. So we're not going to be able to save storage anyways. But having it local will actually, a single disk seek will now get me all of Tim's data, right? For that particular table.
Okay. And that was part of that was driven by the feed to make the feed work. Nice.
Yeah. Okay. So getting at there were tons of other such optimizations. And then once we got into all the functions and we deployed that and we kind of ran it for a couple of weeks, shadowed it for a couple of weeks to see how the shadow cluster is performing, that's when we ran into issues like, every now and then this is, there's a garbage collection happening, or the P99 starts, sucking, SLAs are degraded and so on.
Yes.
And that led to another one of the features that we built, which was we found out at some point The horizontal scalability of Pinot was breaking down. It was like, if you had, let's say, a 20 node cluster for this table, you had another 20 nodes, you're not really getting double the throughput.
Okay.
And the reason for that was the data was actually sharded across all servers, randomly, which means for each query, your fan out is large. So the probability of one of the servers garbage collecting at any given point in time is higher, right? So even though that server is not really hosting any of Tim's data, but the request came to it and it was garbage collecting for some other reason, your query's latency still
the more you have, the more likely you are at any instant for somebody to be garbage collecting. And lots of queries are implicated. The brokers are implicating lots of servers. And so.
So how we went about doing that is, what we call is the replica groups. So it's essentially a way to, fix the fan out, divvy up the servers into groups of replicas. So that this one, so say you have, 15 servers, you have a replication factor of 3. Every 5 servers have one full copy of the data, right?
Okay.
And so a query just has to fan out to just 5 of those nodes. Another query can go to another replica set and so on. So you not only reduce the garbage collection issue by reducing or fixing the fan out, but you also improve the throughput or made it more horizontally scalable because the rest of the replicas are available for, serving other queries in parallel.
Right. So there's just less load on them. Was there at any point a push to move things off heap? Was there ever a migration from on heap to off heap for significant data structures? Because that strikes me that would play into garbage collection.
Yes. So great question. So I think we built Pinot's, all of the Pinot's read-only data, which is essentially the segments, were always off heap since day one.
Memory mapped,
memory mapped, exactly. However, there was a recent feature, one of the most popular ones, recent yet most popular, the upserts, right?
Yes.
Because this is actually introducing mutability in an OLAP system in the true sense, which is really unheard of, right? You're actually going and changing a single row in the table as opposed to backfilling a bunch of rows, right? And you're resolving it at write in just time as opposed to read time. Big difference. That one, in the open source is actually implemented on the heap, like, some of the metadata on the primary key to the record reference is a heap, is stored on a map on heap. In the closed source, we have an implementation which is taking it off heap and, of course, like you said, making it more scalable.
Nice. That's really StarTree Cloud is what we'd probably call that, right? So Cloud occasionally does some other things that open source doesn't. So cool, nice.
Right.
Heap is Heap's your friend. It's the JVM. We like managed memory, and Heap is a friend that just needs things from you sometimes.
TLC.
TLC, just going to need to sit down and talk to you, and you're going to do nothing else for like 3 seconds, which is a long time. So
so I mean, zooming out a little bit, right? I was just trying to give some examples of, it was necessity as well as ambition, or rather fueled by our ambition. It kept on evolving Pinot. There were, once we had solved this, then there were a whole bunch of other non-LinkedIn member-facing use cases, but more of the enterprise side, which kind of have a different problem definition in terms of scale, because you're probably not serving at hundreds of thousands of queries per second, but maybe one order of magnitude less. However, these are being served to users who suddenly have the power to do a dynamic slicing and dicing based on query,
so the queries there are fewer queries as a time rate, but they're less predictable. They're
they're less predictable,
potentially
right?
weird.
Yeah, potentially weird as well.
Yeah.
And that has its own set of challenges that led to kind of us working on more and more indexing techniques. Um, one particular one that I can remember is where in your LinkedIn profile, something like skills is a free form or comma separated string, like, hey, somebody who's has machine learning as well as algorithm skills as well as a bunch of others listed down as skills, right? Now, OLAP way of doing this is you could either have a multi-valued column, or you could flatten the schema and then have every token be a separate row of its own, right?
Yes.
And then do SQL on top. But it breaks down when you want to do queries which are now suddenly venturing into text search, right? Like, give me all the profiles of people who are, for example, in this, satisfy this text search criteria, right?
Yeah.
And all of a sudden you cannot do that. So that ended up us adding text search support in Pinot.
Okay, that is where the text index came from.
Yeah, that's exactly where it came from. Yeah, or rather, the necessity was that.
Did you reach for Lucene immediately when you were doing that? I mean, that seems like what one would do. Yeah.
Yeah, great question. I mean, I think we did definitely. There's always this right balance of do you want to reinvent the wheel versus is the existing solution a way too much stuff for you, more than what you need, rather. So we, because we wanted to prototype it real quick, we said we'll not venture into, we're not a text search system. So we ended up borrowing the engine from Lucene in the first pass. I think a couple of years ago, or maybe last year, one of the open source contributors added a native text search support, which is not Lucene, but and their own implementation. Yeah,
I thought it was a lot more recent than that for whatever reason. So that's
yeah, it might be last year.
History. Okay, it's somewhere.
So many features coming in.
Yeah, I know. It's hard to keep track of them all, and I definitely don't always get that right. So okay, so yeah, now it is native implementation, but still, partial fuzzy matches, regular expressions, all that stuff.
Yeah, all of that. Right.
Nice.
Yeah, so that's there. And then, while all of this was happening at LinkedIn, some of us had, ventured out into other, parts of the industry and sown the seed of Pinot. So it started catching up a lot in the open source community. Companies like Uber started using it and also evangelizing it. And that the phenomenon that we saw at LinkedIn, necessity plus ambition, ended up replicating itself at all the other, or rather, some of the other places as well.
Right. So you're going to get,
for things example, like geospatial.
A geospatial. If Uber is in the game, they need to know where things are.
Yeah.
So, yeah.
So I mean, kind of see a theme emerging here, right? Like, keep pushing the boundary every time, and evolving Pinot.
Yeah. Well, we're getting close to time, and I hope you're enjoying being a guest, because you're going to be back.
Oh, absolutely.
There's a lot more to talk about, but wrapping up for today, I think there's a lot of history in the middle I still want to talk about. But what are some things you're working on today? And we mentioned at the beginning, there's open source, and everything you've been talking about is in open source Pinot, except for the off heap thing in cloud. But are there any other kind of like things that touch core Pinot that are going on in the StarTree world that are fun and
absolutely. Yeah. So there's some. I mean, we recently had the roadmap kickoff for the open source Pinot.
I will link to that in the show notes. Yes, that was fantastic.
Yeah, absolutely. And that has all the details of what's happening in the open source. One of the biggest call out there is the V2 engine, yet another example of evolving ourselves. So Pinot had a scatter gather single stage query execution engine. Now we are realizing that we are crossing into the boundary of, I don't really want to denormalize everything up front. But I also know that, these are joints that I could do at read time in bounded latencies. Can you help me? Right? Can you help me do it in Pinot? So that warranted us to kind of go native about redoing our query execution engine to be a multi-stage engine, which not only lays the foundation for supporting joints, but also lays the foundation for Pinot becoming a more close to a standard SQL engine, right? Supporting all things like nested queries and joints and whatnot. So big thing on the open source side. On the StarTree cloud side, what we're doing is a few things. We're taking our knowledge that we have gained while working on Pinot and applying it in multiple ways. The first is to augment Pinot to kind of make it better and faster for our customers. Especially a lot of them are enterprise, so they would ask for enterprise features like security, RBAC, encryption, multi-tenancy, and so on.
The usual
so
suspects.
making it enterprise ready is one. Cost becomes a lot of concern, or rather infra cost is a big concern for our customers. So making sure that we have features like tiered storage, which give the right balance of cost versus performance to our customers. We're building that on the engine side. But the way I see it is, Pinot is a Ferrari engine, right? But when you are in the game of selling, you cannot sell a naked engine to a customer. You need to build a car around it, right? And what I mean by that here is building a data platform on top of Pinot to make it really easy for our customers to be able to use it, not just for data ingestion, but also for being able to extract analytics out of it, may it be a dashboard, a client, or Tableau connector and things like that. But more importantly, taking it to the next level where we want to abstract the existence of Pinot from a user who really doesn't really care about do I really need to interact with a SQL engine, right? All I care is, here are my data sets. These are the transforms I want to make on top to create more data sets and metrics. Give me a portal where I can define those, and give me a portal where I can query those.
Right? There you go.
Now, what happens in the background? As a user, I don't know if I care. Some of them do, some of them don't. So I think that's our vision there. And then just to wrap it up, taking it one more level, the analogy of the engine in the car is kind of like, now that you have a car, can you make it self-driving, right? And what I mean in this context is, Pinot's an engine built by engineers and for engineers, so tons of touch points in terms of things like initial capacity planning, provisioning, operational scaling up and down, and so on and so forth. And we want to give our customers the experience that they don't really have to worry about it. But at the same time, we also want to not have to do this manually. So we want to kind of take it to the next level where the system is learning from itself, looking at the query patterns and the latencies, figuring out, the benefit, there may be a benefit, if we added a index on this particular column.
Deciding for itself what kind of indexes should be there. Yeah. That strikes me that should be automatable.
Yeah. I mean, we do that. Like, we look at the query log, we look at the response metadata and say, okay, this is missing. So we could just codify that, right? So that would be a good productivity win. Scaling things up and down depending on the workload. And, sort of like kind of having a performance orchestrator, which is learning from the system and then making decisions to self-optimize, right? So this is kind of like what I am driving here at StarTree.
Well, that'll be fun stuff to dig into in some more detail in the future, as well as some other developments in the middle. We'll have you back to talk about new features.
I'm ready to come back.
first of many. My guest today has been Mayank Shrivastava. Mayank, thanks for being a part of the Real-Time Analytics podcast.
Thank you for having me.
And there you have it. If you feel compelled to help us spread the word and grow the real-time analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.